Can't live to live without you. Can't live medio more. Can't live to live without you.
Hey guys! So for this video, we're going to discuss the first law of thermodynamics. But first, let's define what is thermodynamics. Thermodynamics is the branch of physics that deals with the relationships between heat and other forms of energy. In particular, it describes how thermal energy is converted to and from other forms of energy and how it affects matter. It defines a group of physical quantities such as temperature, energy, and heat. So let us first discuss the definitions of each physical quantities. First up is heat. Heat is the form of energy that is transferred between systems or objects with different temperatures. Second is temperature. Temperature is a physical quantity that expresses hot and cold. It is the manifestation of thermal energy present in all matter, which is the source of the occurrence of heat, a flow of energy when a body is in contact with another that is colder or hotter. Third physical quantity is energy. Energy is the quantitative property that must be transferred to an object in order to perform work or to heat the object. Let us now discuss the first law of thermodynamics. The first law of thermodynamics states that energy cannot be created nor destroyed. It can only be transferred from one place to another. Energy can flow in and out of the system. There are two ways for energy to flow, and that is through heat and work. Heat is converted to work, and work is converted to heat. If heat flows to a system, the system gains energy, and that is called internal energy. Internal energy is the total kinetic and potential energy of all the molecules in the system. These are the equation for the internal energy of a system. For chemistry, delta symbol U equals to Q plus W. While in physics, the equation for the internal energy of a system is delta U equals Q minus W. Q represents the net heat that flows in and out of the system. W represents the net work done on or by the system. Work in chemistry, W is equal to negative when done by the system. W is positive when done on the system, while work in physics represents W as negative when done on the system. Work done by the system, positive. Going back into the equation, Q is positive when it absorbs heat energy. So anytime, heat can flow freely into the system. This process is called endothermic, while Q is negative when it releases heat energy. So heat energy flows out of the system and into the surroundings. This process is called exothermic. So let us now proceed to our next topic, which is all about the calorimetry calculations. Calorimetry calculation is the calculation that involves heat and the change in temperature resulting from heat being either absorbed or lost by a substance. Under the calorimetry calculations is the specific heat capacity that represents the symbol S. Specific heat capacity is defined as the amount of heat required to raise the temperature of 1 kilogram of a substance by 1 Kelvin. specific heat capacity may also be reported in the units of calories per gram degree Celsius. Here is a simple equation for calculating heat. Q is equals to M times S times delta T. Q is the symbol for heat, M is for the mass, S is for the specific heat capacity, and delta T is for change in temperature. The formula for calculating the change of temperature is delta T equals to T final minus T initial. T final represents the final temperature, while T initial represents the initial temperature. Let's now proceed to the sign of heat. When Q is less than 0 or negative, the temperature decreases. And when Q is greater than 0 or positive, means that the substance is gaining or increasing heat. So let us now try to solve the given example. Example number 1. How much is needed to increase the temperature of 400 grams of water from 10 degrees Celsius to 70 degrees Celsius? First step to do is to identify the given. S, which is specific heat capacity, is equals to 4.18 joules per gram Celsius. M, which is mass, is equals to 400 grams. Delta T is not given, so let us try to solve and find out what is the value of delta T. So the formula to use for the temperature is delta T equals to T final minus T initial. Delta T equals to T final, which is 70.0 Celsius, minus T initial, which is 10.0 Celsius. Now, the value of our delta T is 60.0 Celsius. So, we are done identifying the given. It's now time to solve. We are going to use the formula Q equals to S times M times delta T. Q is equals to S, which is 4.18 joules per gram Celsius, times M, which is 400 grams, times delta T, which is 60.0 Celsius. Therefore, the needed temperature to raise of 400 grams of water from 10 degrees Celsius to 70 degrees Celsius is 100,320 joules. And that's all for our discussions. I hope you learned something, and thank you for watching.